Hi, and welcome to a lecture on making decisions in our programs using the venerable if statement. In this lecture, we're going to describe how to make decisions which affects the top to bottom evaluation of code. We're going to describe what a Boolean value is. We're going to describe how to make mutually exclusive decisions. And if mutually exclusive is something you don't understand right now, it's totally cool. We'll get to it. And then we're going to recall the logical operators and their truth tables in the same way that you can combine numbers with math things like divide and multiply. We can combine Boolean values, true and false, to get more true and falses. But don't worry about understanding that right now. We'll get to it later. When a Python program evaluates, it evaluates from top down, which means that when it reads your program, it's going to read from the start and go line by line or statement by statement until the end. So with a program like this, it's going to print hello, and then it's going to print it's a nice day, and then Python will go to this next line and run this stuff on the right-hand side of the assignment operator. It'll ask you, how are you? And then whatever you get, it puts it into the answer, and that line is run. Then it'll print, answer, and then it'll print, have a good day, top to bottom. If all of our programs were top to bottom, we would have very boring programs. We need things to help us change top to bottom evaluation. So for example, what if we asked, how old are you? And we store that into age, and then we convert it into a number. But then we only want to print no lottery for you if somebody is under the age of 21 because, they can't buy lottery tickets. How do we do that? This is part of how do we affect the top to bottom? How do we skip a line if somebody is 30? They would get lottery. They'd be like, yeah, I can play the lottery. But if they're younger than 21, then we only want to print no lottery for you. So how do we do that? Well, in Python, we use the if statement. And the if statement will only run its lines, which are the lines that are indented underneath it. You see how this is indented? It's more to the right than the if statement. Let me clear that out again. So we have the if statement, and it's on this column of our, and then we indent over. We hit the tab button or we hit space a couple of times. That indents it over. And the things that are indented underneath the if statement, those are its lines. It's called the body of the if. And those lines will only run if the condition is true. So let's take a look at the if statement really closely. We write the word if, and then we put a space in there, and then we have some condition that is true or false, and then we have a colon. When Guido van Sussem designed this language, he put colons at the end of every line that you could then indent things underneath. And that's how we can just quickly look at a Python program and see that there's a colon there. That means it owns some lines underneath it if they're indented. So the thing after the if is called the condition. This is the condition, and it checks to see whether or not the condition is true or if it's false. If it is true, then it runs the lines that it owns. So lines owned by the if are the statements that are indented. Like right here, we have print is indented over. It's more to the right than the if statement. And the if statement is like, if age is less than 21, if this is true, it's going to print that. If it's not true, it ignores it and it just jumps over the line. It's like, I'm not going to do that. You can have more than one line and they all have to be indented the same amount. So in this case, if age is less than 21, it's going to put no lottery for you. Lottery is silly. Use money better. If somebody's 30, this will be false, and it'll just skip over all of those lines. It'll just ignore them. It'll be like, those don't exist in this program. And that's how the if statement affects the top to bottom, is it will get to an if statement. If it's true, it just keeps going top to bottom. And if it's not true, it skips over to the next thing after all of the indented lines. So let's talk about these Boolean values things. Boolean values are true or false. There's only two Boolean values. With integers, we have an infinite number of integers within the memory of our computer. An infinite number of integers. We can just put whatever integer we want in there. There's an infinite number of them. For strings, we can type whatever we want in there. But for Boolean values, the Boolean data type, there are only two values, true and false. And so we can write those. Is old, false. Is pretty, true. Obviously, this describes me. I'm not old, and I definitely am pretty. When we type these things here, false and true, those are known as Boolean literals. And the same thing that when we do something like x equals 3, Python knows that this is a number. It's an integer. When we type y is equal to 6.28, it knows that this is a number. It's a floating point number, a decimal. When we do something like t is equal to nur, it knows that that's a string. It knows that it's printable characters. Boolean literals are true and false. Now, if you come from another programming language, remember capital letters here. Big F, big T. In other languages, they're lowercase. In Python, they're uppercase because they're so important. So when we do a comparison, this results in a Boolean value. It's either going to be true or it's going to be false, given the state of the program, given the state of whatever is in here. So if we type how old are you and somebody types in an age is greater than 18 will be true if that number is 18 or greater, or it will be false if it's 17 or lower. And then one of those two values gets stored in our variable is adult. So now we have a variable is adult, which will either be true or false given what somebody typed in. Then we can use that in a condition right here for the if statement. If is adult, print don't tobacco. I really like variables like this, is adult. It makes it read really nicely, if is adult. And I know exactly what I'm testing for. I can write it if age is greater than or equal to 18. But all of a sudden now I'm sort of like using a magic number. And I have to read this and like figure out, what does that really mean if age is greater than or 18? It's the same thing because age is greater than or 18 is the condition that we're testing for. But if is adult is so much nicer to read. Sometimes we have to combine comparisons to get the value, the Boolean value that we want, true or false. So a teenager, what is a teenager? A teenager is somebody who is older than 12 years old and younger than 20 years old. That means they're older than 12 years old, which is 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. And they're younger than 20 years old, which is 19, 18, 17, 16, 15, 14, 13, 12. And the and is where those two overlap. Where are those two conditions both true? And in this case, it's the ages 13 to 19. 13 is older than 12 and it's younger than 20. If I said 25, that's definitely older than 12, but it's not younger than 20. So this would fail. 25 is not a teenager. So let's take a look and see how we can do that. So we'll say, how old are you? And we'll convert it to a number. And now we can use that and operator. What's nice here is we actually use the word and. It makes it very easy to read. Age is greater than 12 and age is less than 20. That's so much easier to read. In other languages, you have weird things like ampersand, ampersand, which is just hard and ugly to read. Yuck, who wants to read that? Age is greater than 12 and age is less than 20. That makes a teenager. There is a teen. Age is greater than or equal to 18 is adult. And or operator. We're going to look at those right now. So here's our Boolean and operator. Let's take a look at the definition. The and operator checks to see that both of the values are true. If they're both true, then the and is true, like we saw. Is teen is only true if age is greater than 12 and age is less than 20. Now, what happens if we want to test if somebody is an adult and they are a teen? So is adult and is teen. What integer values make that true? What integer values work so that is adult and is teen are both true? I'll give you a moment, pause the video and figure it out. Okay, welcome back. We're looking for ages greater than or equal to 18. So that's 19, 20, and so on. And then we're looking for ages between 12 and 20. So those are ages like 13, 14, all the way up to 18, 19, and 20. So which numbers are in both of these sets? It's and. So which number is in this set and in this set? Oh, I guess there's an 18 here too, because 18. So which numbers? Let's take a look. Is 18 in both sets? The answer is yes. Is 19 in both sets? The answer is yes. Is 20 in both sets? No, because 20 is not supposed to be there. It's less than 20. So only the numbers 18 and 19 will make all of this true. If age is 18 or 19, then they are both an adult and a teenager. Is adult and is teen. So let's look over here. Again, left one is true and the right one is true. Then when we do the and, it's going to be true. Otherwise, it's always false because we're expecting both of them. They both absolutely have to be true for the and portion to be true. So is adult and is teen is only true if a person is both an adult and a teenager. All right, now let's look at the or operator. The or operator looks at least for one of the operands to be true. So true and true is true. True and false is true. False and true is true. And if both of them are false, then it's false. This is kind of like the opposite of the and. In the and, if both are true, then and is true. For the or operator, if both are false, then it's false and the rest are true. So the or operator looks to see if at least one of the operands is true. Now this is kind of different than the way that we use the word or in English. Sometimes in English, we use it to mean mutually exclusive or, like your pet is a dog or a cat. It can't be both a dog and a cat unless it's Cat Dog from Nickelodeon. Cat dog. But normally when we use the or operator in English, we mean it's a choice between one or the other. In Python, when we use the or operator, we mean at least one of them is true. So if they're both true, or is still true. So is adult or is teen is true if is adult is true, is teen or true, or both of them are true at the same time. So what integer values make this true? Up here, is adult or is teen. Take a moment. For somebody to be an adult, that's 18, 19, 20, and more. Over here, it's 13, 14, 15, 16, 17, 18, or 19. It has to be in at least one of these. The or means that it's either of them or both. Remember, or both. So what numbers are in either of these? Is the number 0 in either of them? No, so that would be false. Is the number 10 in either of these? No, so that would be false. Is the number 15 in either of these? Yes. So 15 definitely means that somebody is an adult or they are a teenager. How about 20? 20 is true because it's over here. They are an adult. So is adult is true, is teen is false. But together it's true. What about the number 18? 18 is in both of them. And even though it's in both of them, it's still true. Okay. Or means it's always true unless both of them are false. Then it's false. So sometimes we want the opposite of a value. So for example, we have a variable that is adult. But what if we want to know if they're not an adult? How do we know that somebody is not an adult if we have a variable that says is adult? So if it's true, we want to find the opposite of that, false. And if it's false, we want to find out if it's true. So we want to flip it. To do that, we use the not operator. Not operator. I'm not really a big fan of the not operator, because it can be a little confusing when we read things. But let's take a look at this code because code is pretty easy. Is adult is set to the comparison age is greater than or equal to 18. So if they're 20, is adult is true. And if they're 10, is adult is false. Is child is the opposite of that. So we say not is adult. See, that's really that's the weird part right there where we say not is adult. It's like speaking German. It's weird. It's like you have to put the modifier in front of it. So weird. We would say something like is not adult, but that's not the way that we do it here. We say not is adult because that's the name of the variable, and the not operator works on that variable to turn it the opposite of what it really is. Not is adult would be the same as not age is greater than or equal to. You see, this is why I don't like not operator sometimes, because it's just so weird to read that. Not age is greater than or equal to 18. If I'm going to type that out, I'm just going to type age is less than 18 because that's the opposite. That's the opposite of what we're saying there. But not is adult is easy for me to read as well. Not is adult if I already have that value stored in there. not is adult, what values? I've already answered that, so you can figure it out yourself. But if the value is false, then not false is true. And if the value is true, then not true is false. So it flips that around. It changes it to its opposite value. How can we work with trues and falses with our if statement? Sometimes we want to just like, if this is true, we want to do one thing. And then if it's not true, we want to do something else. And that's when we include the else clause, which is an optional clause. It's optional. Notice that it's at the same indentation level as the if. So that means this if and this else are tied together. They're part of the same thing. So when Python looks at this, it says, well, let's say age is equal to 20. So if age is equal to 20, it gets to here. If age is greater than or equal to 18, that's true. And so it will go to the next line, print the body of that if, and then jump over the else clause and continue somewhere else. If, for example, age is equal to 10, it will get here to this. If age is greater than or equal to 18, it says no. And then it will go to its else clause. And else is just like, I just do everything if the other thing doesn't. And so else is like, I'm totally going to print my thing. And then it jumps to the next line and does whatever it should. All right, so here we get to this mutually exclusive thing. Given an age, we want to print whether or not they're a child, they're a teenager, or they're an adult. Mutually exclusive choices here. It's one of those three things. It can't be a child and a teenager and an adult according to this right here. It's just going to decide I need to print only one of them based on the age. So if age is equal to 10, Python is going to get to this if statement and it's going to say, if 10 is less than 12, that's true. It's going to go to its print statement, print that out, and then jump after the entire thing. The if, elif, else, okay? Elif means else if, and we're going to get to that right now. So what happens if age is equal to 14? It gets here to if age is less than 12, 14 is not less than 12. So it goes to its elif, and it checks that one. If 14 is less than 20, that's true. So it will print this, and then jump over everything and go to the next line. And then finally, if age is equal to 21, it'll try this one out. If age is less than 12, that's false. So it'll go to the elif. If 21 is less than 20, that one's not it. So it'll go to the else. And the else is like, I do everything. And so it will print out that and then go to the next line and do it. It allows us to skip multiple lines based on a singular condition. I want to point out that having if, elif, else is different than having separate ifs, okay? These two ifs are not together. They're not part of the same thing. They're separate if statements, whereas this elif is tied to that if. So just like we had in the last one, if age is equal to 11, what happens? It'll come here and it'll say, is 11 less than 12? The answer is yes, so it will print child, and then it will jump after the entire thing and run the next statement, whatever it is. Over here, if age is equal to 11, it gets to this and it says, is 11 less than 12? The answer is yes, so it will do its thing, and then it will jump to the next line and start doing that. And then it gets to this one, is 11 less than 20? It will print teenager as well, and then jump to the next line. So if you want these things to be connected to each other, you have to use elif. Otherwise, Python will be like, this is separate from this, and I'll give them both a try. We're going to find ourselves writing nested if statements sometimes. So let's take a look. If age is less than 12, we're going to go into this block. And now this block has another if, which says height is greater than 180. So if this is true, it's going to print you're tall because they're 180 centimeters, and that's kind of tall for a 12-year-old. But how did we get here? We had to pass this gate, age is less than 12, and this gate, height is greater than 120 or 180. So a nested if right here, where we have this nested if, that's the same as writing it like this. If age is less than 12 and height is greater than 180. It's up to you to decide how you want to do this. Sometimes some people are like, this left side makes much more sense to me. And some people are like, I like to write out age is less than 12 for all of these. It's up to you. There's more than one way to write these things. There's more than one way to be able to do programming. So in summary, decisions can be achieved with if statements. If statements are going to skip things if stuff is false. A Boolean value is one of two values, true or false. You can do mutually exclusive things with if, elif, else. And the logical operators are and, which is only true if both of them are true, or which is false only if both of them are false, and not, which flips it around. That's great. Let's take a moment to see it in action. So here's problem 1 from the if chapter. It's called number analyzer, which that's an S. That's weird. It's kind of like British. Analyzer. Look at that. So it says, write a program that asks the user to enter an integer. With that value, the program should display it positive if the number is greater than 0, negative if the number is less than 0, and 0 if the number is equal to 0. So we already have a decision here, which it will only print one of three things. These three different outputs are mutually exclusive. So because there's three things there, this is mutually exclusive. And we're going to use, because we have three, we have to use if, elif, else. That's how we should do it. Then down here we have the program should display even if the number is even and odd if the number is odd. That's also mutually exclusive, but there's only two choices. So we could just use something like if else for this. If something is true, do one thing, otherwise do the other thing. So let's go ahead and write this program. Our number is going to be the result of the input. What is your number? Like that. We're going to change that actually into an integer. Why not? Because it has to be an integer. According to our thing here, it says enter an integer. Now we're going to write our first mutually exclusive thing. It needs to do positive, negative, or 0. And we can write this any way we want. We can follow the instructions, which says if the number is greater than 0, print positive. We can do if number is greater than 0, then print positive. And the next thing would be if the number is less than 0, print negative. So that's an elif. Number is less than 0, print negative, just like that. And then finally, print 0 if it's equal to 0. We can do elif number is equal to 0, print 0. Or we can identify the fact that there's no other number it could be. If it's greater than 0, it's positive. If it's less than 0, it's negative. The only other number it could be is 0. And so in this case, we could just type else. Again, you can solve this problem in more than one way, and it always works if you do it correctly, but you have options here. If we decided not to follow the instructions, if we decided to do it backwards, we could do if number is equal to 0, then we'd print 0. Then we could say elif number is less than 0, then print negative. And then we can do else here, because we know that that number is going to have to be positive because it's not 0 and it's not negative. Or we could do elif number is greater than 0. Whatever you'd like. Again, there's more than one way to solve it. Then finally, we have the if else for even odd. Again, that's another mutually exclusive choice. Another number can either be even or odd and not both. Like your pet can be a cat or a dog and not both. So let's go ahead. If number mod 2. So if a number mod division by 2, again, mod tells us the remainder. So if we divide a number by 2 and the remainder is 0, then that's got to be even. We can do an elif number mod 2 is equal to 1, then we know it's got to be odd. But the idea here is that those are the only two things. So we could also just do else here. Let's go ahead and give this a run and see if I made this okay. Run it through. What is your number? 10. It's positive and even. Great. I'm going to run it again. -3, negative and odd. How about 0? 0 and even. That's amazing. Now let's watch it actually run step by step. I'm going to put a breakpoint here on line 14, which is the first line of real code. You can't put a breakpoint on a comment. It has to be here on an actual line of code. And I'm going to step through step by step what happens. And it's going to be really interesting. So I'm going to debug this. It's going to start up its thing. And now this highlighted thing is number equals input. We're going to watch this yellow line jump to different places on the if statements. It's going to jump over things it doesn't need to do. So over here, by the way, are the variables that we're declaring. So it's here at number. I'm going to click this, go to the next line, step over is what it's called. Click that and it's going to run it. So over here is what is your number, and it's waiting for me. So I'll go ahead and put in 11 and I'll hit enter. Now, if you can see, number is equal to the string 11. So on this line right here, number is currently 11, and I'm going to click step over, and now number is the number 11 because it ran this, turned it into an integer, and put it back in a number. And now I'm here. So if number is equal to 0, is that true? No, that's not true. So when I click step over, it's going to go to the next elif. It skips this line. It's like, that's not true, so I'm going to skip it. And so now it's on this one. Elif number is less than 0. Is that true? The answer is no. So it's going to skip this line. Boop. And now, is number greater than 0? The answer is yes. So now it will actually print that line. You see how it skipped over these lines? This is affecting the top to bottom evaluation. We can now skip lines that don't make sense for our program given a state, given the input from somebody, given values in a variable. So it's going to print out positive. Boop. Now it says positive. Now it's going to do this. Number mod 2 is equal to 0. What is that? So what I'm going to do is I'm going to come over here to watch, and I can declare things. I'm going to click plus, and I'm going to type in number mod 2. And it's going to tell me what that value is. It actually tells me that's 1. So is the number mod 2 equal to 0? The answer is no, because it's 11. It's an odd number. So it's going to skip this line and go to the next thing. Boom, there it is on else, and it just jumps over the else, and it's like, print the odd, Mo, print the odd. And it does. And then my program is over. And so that's how if statements work. It jumps over lines until it finds something that evaluates the true, or it jumps over lines until it gets to the else. And it's just like, I'm going to do the else because that's all I've got.